Okay, so now we have a question number 9, and the question goes: find an elementary mix E such that B equals E times A. Um, if you don't get this question at first, I would just try all of these and find which one multiplies with so if B is equal to -1, -2, 2, and 4, find which one of these actually multiplies to get that. There's a long way of doing it, and there's just a trial and test method. And when you test the method, you'll find that um, B is the best answer, and you will get these numbers. When you multiply E, which I can just write A, B, C, and D, with A. What is A? A is 3, 6, 2, and then 4. You might also be thinking that there could be another method where we could multiply both sides by the inverse. A inverse times B equals E, right? But the problem here is the determinant of A in inverse equals, you know, equals 0. AD minus BC, so AD minus BC equals 0. And the matrix A is actually not invertible. So this is not invertible, right? Because you get 12 minus 12 equals 0. So you can't do it this way. So it's a trial and test method, and you will find that B is the best answer. Now number 11. Number 11 is actually it's a question that actually tests if you have actually read the textbook or not. In short, I will go over the rules associated with number 11. Number 11, there's a couple of rules you have to first know by heart about determinants and how they act when you manipulate matrices. What happens to the determinant? Well, one thing I can tell you is if you multiply by if you multiply by a constant, and that's it, just a constant, k, right? The k is just the determinant of original. Okay, so it's just k times original. Now, this is rule number 1. Rule number 2 is if you switch 2 rows, you just do the negative of the determinant original. Okay. A third rule is if you add or subtract at and this determinant same. So the determinant doesn't change. -1, okay, same, and for the fourth option, you can also take a transpose and the determinant same. Okay, in this case, I'm just gonna talk. You're gonna have to find ways that you can manipulate this right here and get the right hand side. What I've seen from now is that they did 8 times R2, changes R2, which changed the determinant to 8 times 4, which is going to give us 32, right? And then they also switched this row with this row. So R2 with R3, so that's going to equal -32 because you just multiply by a negative. What they also did was they added 8 times R1, -8 times R1, plus plus row 2. It's row 2 now because they switched. They added this, and remember what I said about adding, regardless of this multiplying on the side, the determinant doesn't change. It's only if you multiply a single row or single that it does change. So in this case, the determinant actually doesn't change, and it just stays at -32. And your answer is B. And yeah, so I would memorize these determinant rules off by memory and know the basic concept behind them. Other than that, that's how you solve that question. And yeah, see you around.